How are you, Moshe?
Good. Glad to be here. Thanks for having me again.
From your incredible background, what was the chapter that you learned the most from, in your opinion? Was it Apple, Tesla?
Yeah, I think actually the where I really grew up as an engineer was in the IDF, in the Merkava Tank Development Unit when we worked on the very beginning of the program of the NAMER, the heavy armored personnel carrier. And I think the years in the IDF were the most intensive, and were really developed as an engineer and learned anything I know that served me very well in the later roles.
Oh, wow. I felt that working for Elon Musk at SpaceX or Tesla is much more demanding, but you're surprising me.
Yeah, and every role has a unique characteristics, but I think the 6 years in the military developing armored vehicles definitely were the most intensive experience.
Oh, wow. And you know what? I read about what you do at Wild Wet Systems, and it was mind-boggling. It was it was like taken from a Hollywood like a science fiction movie. So could you elaborate about this a little bit? What are you doing there?
Sure. Yeah, so in a nutshell, we're developing smart kinetic countermeasures for drone threats. In the last few years, we saw the increased use of drones in the battlefield. We see what happens in Ukraine and Israel, and what it really reveals is how Western defenses are not really prepared for this new type of asymmetric warfare. We see how US is spending $2 million worth of cruise missile to take down every $2,000 worth of Houthi drone. And this is obviously not a very sustainable way to move forward in this new world with this new type of threat. And we identified basically a lack of scalable, cost-effective solutions. And we see many companies developing single-use kamikaze drones, but we figured this isn't good enough to really change the equation to make it much cheaper to defend than mount an attack. And we believe that every drone that the military is buying should be smart, effective, but also reusable. So we developed special kinetic payload that can be deployed from any light drone, and a compute module that uses Edge AI to operate basically as a co-pilot and handle target tracking and interception, and ultimately enabling fully autonomous fleet operation against these type of threats, making sure that the good guys win.
Oh my gosh, super impressive. And thank you for making the world a safer place,
Sure.
especially in those days.
Yeah, happy to do that.
And you know what? A lot of us mechanical engineers, where some of us are junior mechanical engineers, some more senior, but looking at your CV and your experience, would love to learn what are your best tips on what to learn, what to master. Um, what could we do better to become better engineers? Because we do see how AI changes so rapidly. We see that it didn't really penetrate it into our domain, not drastically, like in software engineering and something. And you've been there. You saw the most advanced and innovative companies, and now you're doing innovative in your own company. What would you say to the 20 years younger Moshe if you could talk to him?
Yeah, so I think this is typical questions I get asked by a lot of engineers that see the type of companies on my background and ask how to plan their career and what to focus. I think the first advice that I always give is the most important thing to focus on is fundamentals, to be able to dissect problems analytically and solve from the perspective of first principles. And over the last few years, I interviewed many candidates with different experience levels and from different universities, and it's sometimes surprising to see a lot of candidates struggle with things like basic things like free body diagrams. And I don't know if there was a shift in how engineers are trained today, or maybe there are different trends of what kind of advices they get on what to focus on, what's important, but what I say is always keep sharp on fundamentals. The things you learn the second or third year as an undergrad, I think this is this is what really gives you the capability to transition from different domains, different industries, but always be able to solve problems from really fundamental and first principles. Um, And the other thing that, especially for engineers in the earlier stage of their career, I think that it's important to always be curious about how to put theory into practice. I think one of the things that I vividly remember from school is basically how boring GD&T was. I was literally falling asleep in GD&T and and drawing creations. I can't
Likewise.
imagine any more boring class than that. But you only learn to appreciate how important it is when you start working. And
Mhm.
once you need to start making parts, and then you really understand how important it was to pay attention to GD&T and to really fitments and thermal expansion and wear and coatings and corrosion and different manufacturing processes and all the stuff that aren't that trivial once you start to really get parts done. So um, I say be curious about the full life cycle of a part, not just the how to make nice CAD shapes, but really how things are made. And I also remind you to be curious and maintain healthy skepticism. Always ask why and understand why. Don't just take any assumption for granted. I mean, if you scroll through your feed and you see probably countless cool videos of endless possibilities with additive manufacturing, you might be tempted to think this is how the future is now and that the only way to make things is 3D printing. Well, obviously it isn't. Often it's not even your best option, neither for production or for prototyping. You might see many aircrafts using composites and things that composites are the best and the only material you should use for anything that flies. And obviously it isn't. So always ask why, understand there is always more than one correct answer for every problem, and everything is basically a trade-off. And so I think that's the most important thing to really always never take anything for granted. Always question why and imagine that there are more than one correct answer. And to that end, never fall in love with your own designs. Always be ready to let go of your own ideas if you're presented with alternative ideas. And it's always good to be passionate about something you came up with, but don't let your passion blind you from cold hard numbers. And um, and I think we discussed, I think before, what kind of companies people like to work for, or aspiring to work for, and I think for early stage of the career, I think, and that's just my personal view, I think you should want to work for companies that mass produce products as opposed to companies that mostly do one-off or niche R&D. And the reason is that in mass production environment, you really get exposed to many dilemmas of design choices, material options, manufacturing methods, and you really need to make pragmatic trade-offs, and usually in a pace that also lets you quickly see your work come to fruition, and you learn and improve quickly from iteration to iteration. That's not to say that working for NASA, for example, wouldn't be a good way to kick off your career. But the pace and focus in such an environment would be very different than for, say, SpaceX. So obviously, it's also a matter of personal preferences. But if your goal is to really gain hands-on experience and confidence in your own design skills and your engineering skills, I think fast-moving mass production environment is usually a better way to develop your skills as an engineer.
Mhm. And Moshe, along your career, you saw different things changing in mechanical engineering. And I think today, and we talked about it, the world of mechanical engineering and mechanical engineers in general, from my point of view, is divided to I call it the people of the old world order and the people of the new world order. So the first ones are protecting their best practices and how-tos religiously. And they have a very good reason. Like, when we choose both, when we write a document, when we choose a coding, whatever, it's because we had an error that sometimes cost on human lives, right? And we have our best practices and guidelines, and we want to follow them religiously, and anything that could shake this old world order is dangerous in some sense, right? And the other ones, maybe the people that are looking for any new stuff, right? Any new stuff, if it's good or not or whatever, those are the people of the new world order. But I think the vast majority is in the middle. And people are, on the fence, and they know that the world is going to change and AI is going to change it in some way, but no one really knows how it's going to change, right? So in your view, how our profession, mechanical engineering, mechanical design, is going to change in the next decade? So a mechanical engineer in 5 years from now, how is going to leverage AI in his or her work, in your opinion?
Yeah, so I think we really are living through a massive change that is, I think, bigger than everything we experienced before. And I'm usually very cautious about hype. But I think what we see with AI today is already changing how we interact with systems on our daily basis, and I think it's only going to accelerate. I mean, you already see searching online moves from Google to Grok or ChatGPT in a natural human-like talking and asking questions. And I stopped using Google. I mean, when I search for something, I immediately go to Grok. Google is just commercials right now. So I personally don't even use the search bar anymore. And I think a lot of people get used to this type of experience, and we see how quickly this accelerates. I mean, we already see images and videos and voice generation today already reaching levels that are becoming hard to distinguish from real footage. And it's obvious where things are headed. And we just, last week, I think we heard Meta, Facebook, and other tech giants doing force reductions, citing the increased use of AI to replace various jobs. So this is happening, and people are already using these tools to write code and summarize content and arrange data. So people practically are using these tools for doing real professional work. When it comes to mechanical engineering, I think there is still some way to go before you can trust AI tool to really make full CAD and drawing package for you. Um, but it's not that far away. And now that I say the word trust, because the capability is pretty much already there, more or less. I mean, there are various demos online showing sketches or images or text prompts to a 3D model, and there are tools that can create fully detailed drawings with GD&T. But you still can't trust it to get it right all the way. You still need to see you still see like across all tools this behavior that the same prompt may produce different results, and this is something that in engineering context it will need to be further developed such that results are trustworthy, consistent, and accurate. Every time if I give the exact same prompt for the exact same set of parameters, I need to get same result. It can't be that you get completely different results. So I think there's still a long way to get there in many aspects. But I'm 100% sure it's coming and sooner than most people think. I mean, think of Tesla full self-driving. 7 years ago, it was already very impressive, the copilot, right? The autopilot. But it still needed much more constant supervision, right? Today, it's really you don't need any supervision. I mean, if you try today, if you go into a Tesla that has full self-driving, it's amazing. I mean, you'll think a person is driving the car. So imagine 5 years from now how it's gonna look like. And 10 years from now, I doubt your children will even bother getting a driver's license. So they'll see you and laugh at you while you keep your old car with the steering wheel. So we see that happening, and it's happening in real time, and it's gonna happen the same in mechanical engineering and any engineering field. And also the other aspect in engineering, in mechanical engineering world specifically, I mean, there is a heavy baggage of many legacy tools. The industry is basically dragging along CAD and PLM tools that have code base from the 90s. And it often feels this way. I mean, you interact with various different platforms today, and some of them still feel like you run UI from the 90s.
Except
Um,
of OnShape, which is great.
yeah,
Just I
yeah.
needed to say it.
I'm a proud Onshape user too. So
Yeah, yeah,
Onshape, yeah.
yeah. All of us.
Talking about many other tools.
Sure, sure, sure.
And the fact is that most tools mechanical engineers work with today are extremely outdated and often unproductive. And personally, and I know I'm gonna get some pushback on that, but I find all PLM tools an unnecessary evil. And that's a debate for another day. But PLM tools, and it can be soul draining task for engineers to spend time on various PLM tools and all the peripheries. Um, and it's hard for the big CAD and PLM houses to make meaningful improvements because they have to be backward compatible with this and these are very complicated platforms. But in this new era, with these new potential capabilities, I think we might see the use of AI coming soon as a potentially as a top layer to streamline or maybe completely replace clunky user interfaces that have really been neglected for a long time. Again, not pointing the finger specifically, I think this is a common in the industry that a lot
Sure.
of tools are outdated. And I think AI will basically come to aid in that regard. And aside CAD, I think people are already getting used to search for formulas or industrial components like you saw in McMaster, or just ask ChatGPT to refresh the memory on some formula or teach them something. So people get used to these tools already, and they will likely expect to have similar capabilities at their fingertips in their professional lives. So when they come to work and in the work environment, it's going to be they're going to expect something like ChatGPT at their fingertips. And I think what you mentioned earlier, the point about tribal knowledge, I think this really is going to be the path to preserve and disseminate tribal knowledge in an organization when you have the tool living in your database, in your organization, learning from your engineer and basically giving your engineers advice based on what other team members did in different times, different projects, and that's really a realistic way to preserve tribal knowledge and keep it going without hoping that the principal engineer that sits in the end of the hallway will always be there to answer questions.
Yeah. And you know what? We were super fortunate, and me specifically, I was super fortunate to talking to you years ago when we just started this venture called Leo AI, because we looked up to you and your experience, and we we talked to you about how you envision AI and what you think is gonna be the best use case, and we kept in touch along the way. And every time that we launched something significant, we talked to you just to make sure that we were on the right path. And we were very happy to see that even though there is a lot of hype about AI and BS AI, you found something different about Leo. And I would love to hear from you. What do you think makes Leo stand out? And what do you think is the best value that it provides now to engineers?
Yeah, so I think some of the important items that they saw in your approach is context and explainability. For example, you demonstrated how you can ask a tool specific questions about a specific feature in your design, and you get detailed answer explaining why and what references it used and what assumptions it made. And so it really how it reached to a certain conclusion to give you a specific recommendation. So this is very important, and when a tool lives within your organization, learns from your database, understand the context of the question, the specific model that you're trying to design, how it is similar to other projects or the assemblies, or it really that's how you guarantee that the tribal knowledge is really put into action. Like as I mentioned, you don't always can count. They have a senior engineer, principal engineer down the hallway to be available to mentor you every day. But if you have this sort of AI copilot that can tell you how these two parts that are in contact in your model, maybe they should have dissimilar materials because your risk of galling. And here are the models and design reviews that your colleagues made in the past, and they have similar characteristics and similar to what you're designing here. So this is why this part needs to be stainless steel, this part needs to be carbon steel, and this should be your coating, and you're missing that piece, and so on. So all this stuff, I really see a real path to how AI really can become that, co-pilot or advisor that organizes this information so people don't kind of reinvent the wheel over and over in an organization.
Mhm.
Um, So yeah, and the other thing, you laughingly said, you don't want your AI to be trained on some random Reddit page, right? And this,
Yeah.
uh, again, this is if you can't just have just a random general ChatGPT that is fed from all over the internet, and you might ask him, "Hey, is the Earth flat?" And yeah, it's been fed from with some Reddit page that explains all the reasons why Earth might actually be flat, and you might think it's actually a legit option, right? So you don't want that in when engineers are doing design work, but you do want your engineers to be fed with legit information based on professionals that are already working in your organization. And if you have a long and established database, then there's a lot to learn from. So that's really important and really practical way to train your AI and really be that thing that, we keep using this word tribal knowledge, but that's really the core of engineering. It's not just the patents, it's not just the manufacturing method, it's really the tribal knowledge, the know-how. That's the most important thing in every organization. And having an AI tool that really preserve and disseminates this information to new engineers and keeps everybody at their best so people don't reinvent things, don't repeat mistakes from the past. I think that's really the opportunity in what you're building.
Hearing things from you is super meaningful for me, Moshe. And you know what? We talked about, we don't have much time, unfortunately, but I got to ask this question because now let's be more granular. And we have people here from, I just saw the results of the poll, right? From the territories, from different places around the world, and from different industries. So, talking about mechanical engineering, it's super generalizing. We talked about what's going to change in mechanical engineering. But now the question is, who do you think is going to change first? What territory, what industry is going to change first? Is it, the automotive, which is claiming to be super innovative, but, they have their own regulations and a lot of things that guiding them to be very conservative, or maybe oil and gas, whatever. What do you think? What's the
I don't
order
think
of industries?
I don't think it's a specific industry. I think it's gonna happen everywhere at the same time. Everybody that uses CAD um, and again, you mentioned regulations. I mean, all these things, these are additional things that live outside CAD, and it's very hard for engineers to collect all this data, to find all this data. If you ask a new design engineer that just joined an automotive company and he needs to be able to design a seat that conforms to a specific recent regulations, and now he has nobody to ask. He'll probably go on the internet and try to figure out, piece together how all these regulation pieces fit in where he needs to put a certain label on the seat.
Mhm.
Uh, so, sometimes things as simple as that. So you
Yeah.
can, it's gonna happen everywhere, and it's gonna be fed with different sources of data. And I think AI is just gonna be like something that you expect to have. These tools, something you expect to have, and especially in things that are both deterministic at the same time, because engineering is deterministic. I mean, there are
Yeah.
rules, there are analytic process for everything, and also regulations, so even though government write them and oftentimes they're conflicting.
Yeah.
But how regulations tie back to engineering, and your car is basically governed by millions and millions of pages of not maybe thousands, maybe not millions, but thousands of pages for regulatory compliance that drive certain features in how a car is built and made and tested, right?
Mhm.
But it'll take a long time for an engineer that is new to the industry to understand everything, and companies, they employ people who are specialists in just knowing the regulations and guide the engineering teams how to follow these regulations and how to adjust the design. Every new project and every new engineer, it's re-educating those new engineers and learning how do you need to design something to fit these regulations. And I think these kind of jobs actually, just like again last week, Facebook Meta said that they're cutting a certain percentage of the workforce because that's what moved to AI. I think a lot of these jobs will move to AI. You won't need a whole team to keep track of regulations. You'll have one person with a ChatGPT. So I think we will see this. This is, I mean, we already see it changing in front of our eyes. Um, I just hope that my concern a lot of times that people will get dumped down when they get used too much to use these
The
tools.
generated, yeah.
But at the same time, I think mechanical engineering is too complex to completely replace with AI, but we will see a lot of it shifting, and we will see, the emergence of authoring and generation of stuff by AI. And I think again, with this tribal knowledge and combined with the capabilities to create fully detailed 3D packages, I think you're building the foundation for what's coming next, which is, hey, design me a car that can carry three people, 500 pounds in the trunk, and this and that, and your AI tool will just in 3 minutes come up with a fully detailed CAD model and fully detailed GD&T drawing. So I think it's coming, and I think this is the foundation, and I think we're gonna see it everywhere. And just like self-driving, I think again, your kids probably. How old is your youngest?
Youngest is 2 months old.
2 months old. Well,
Yeah.
congrats. I'm glad you still have the energy to be here and talk to us. And
I'm
so,
not, just a lot of coffee. A lot of
but
it.
but I don't think he'll even make a driver's license. I mean, I think he'll laugh in the idea that you once used a steering wheel. So. I think in 10 years from now, the way we use and make parts will be completely different than what we do today.
Yeah. I totally agree. And wow, Moshe, I could talk hours and hours with you, and I'm looking forward to the next time that we'll talk. And by the way, just between us, right? We're looking forward to more collaborations down the road and do great things together. In the meantime, guys that are here, right, they want to take part in a cutting edge company that changes warfare with technology, feel free to reach out to Moshe. He didn't tell me to say so, but if I were you, I would do it right now. And Moshe, thank you so much for your time.
Sure.
Really,
Happy. Thanks for
thank
having
you.
me.